Hello students, today we are going to study telecommunication traffic. Introduction. When any industrial plant is to be designed, an initial decision must be made as to its size in order to obtain the desired throughput. In telecommunication system, it is the traffic to be handled. This determines the number of trunks to be provided. Trunk. In teletraffic engineering, trunk is used to describe any entity that will carry one call. It may be an international circuit with a length of thousands of kilometers or a few meters of wire between switches in the same telephone exchange. Trunking. The arrangement of trunks and the switches within a telephone exchange is called trunking. Traffic variation in minutes. The figure shows the average traffic in minutes. It shows the number of calls in progress on a large telecommunication system. Example is telephone exchange made over a few minutes. Here, the number of calls varies in a random manner as individual calls begin and end. Figure shows x-axis time in minutes and y-axis call in progress. You can see in the figure number of calls varies in a random manner. Traffic variation during a day. So we can see that traffic will be more during some days and traffic will be less during some other days. So as shown in the figure, the time x-axis is the time of duration and the call in progress. So we are measuring from morning and night, AM to PM. So figure shows the way in which the average traffic varies during the working day at a typical medium size telephone exchange or a transmission route. There are very few calls during the night. The number of calls rises as people go to work and reaches a maximum by the middle of the morning. It falls at the midday as people go to home from working place, and it has a further peak in the evening as people make social calls. Busy hour. It is a period of 1 hour which correspond to the peak traffic load. In figure, busy hour is from 10 a.m. to 11 a.m. So you can see in the figure between 10 a.m. to 11 a.m. this busy hour, more calls during that busy hour. Unit of traffic. Traffic intensity or simple traffic is defined as average number of calls in progress. Unit of traffic is long. On a group of trunks, the average number of calls in progress depend on both the number of calls which arrive and their duration. The example in figure shows how 1 furlong of traffic can result from one trunk being busy all the time. For each of two trunks being busy for half of time, or from each of three trunks being busy for 1/3 of the time, as in figure A, B and C. So in the figure you can see that free is not shaded. Busy trunk is shaded. From the definition of the furlong, that the traffic carried by the group of trunk is given by A equals CH by T. A equals traffic in furlongs. C is average number of call arrival during time T. H is average call holding time. If T is equal to H, then A equals C. Thus, the number of calls arriving during a period is equal to the mean duration of calls. Congestion. The situation where all the trunks in a group of trunks are busy and so it can accept no further calls. This state is known as congestion. In message switching system, calls that arrive during congestion wait in a queue until an outgoing trunk becomes free. Thus, they are delayed but not lost. Such systems are queuing or delay systems. In circuit switching system, example telephone exchange, all the attempts to make a call over a congested group of trunks are unsuccessful. Such systems are called as lost call systems. In lost call system, traffic carried equals traffic offered minus traffic lost. The proportion of calls that is lost or delayed due to congestion is a measure of the service provided. It is called as grade of service. For a lost call system, the grade of service B can be defined as B equals number of call lost divided by number of calls offered. Hence, also B equals traffic lost by traffic offered. Proportion of the time which congestion exists, probability of congestion, probability that a call will be lost due to congestion. Example, we can take one problem. During the busy hour, 1200 calls were offered to a group of trunks and 6 calls were lost. The average calls duration was 3 minutes. Find traffic offered, traffic carried, traffic lost, grade of service, and the total duration of the period of congestion. Traffic carried equals A equals C into H divided by T. So number of calls is 1200 into 3 minutes divided by 60 equals 60 longs. Traffic offered is A equals C into H divided by T. So 1001 now 1194, that is 1200 minus 6 will get 1194 into 3 divided by 60, 59.7 longs. Traffic lost is C into H divided by T. 6 into 3 divided by 60 equals 0.3 longs. So GOS is equal to traffic loss divided by traffic carried. 0.3 divided by 60, 0.005. The total duration of periods of congestion equals 0.005 into 3600 equals 18 seconds. Traffic measurements. It means that measuring of busy hour traffic is necessary and regularly operating company need to measure and must keep the records. By the definition, measuring the traffic carried amounts to counting calls in progress at regular interval during the busy hour and averaging results. In modern stored program control system, the central processor generates record of the call that they will set. So we'll take an example. Observations were made of the number of busy lines in a group of junction at interval of 5 minutes during a busy hour. The results were as shown. It is therefore estimated that the traffic carried in a longs was, adding all the values divided by 12 equals 12 longs.